Hello, we're on 8.04 today for Algebra 2. We're going to talk about synthetic division. Very exciting. It's a shortcut for long division. Also, before we get started into the notes, I just wanted to let you know what's coming up for next week. So on Monday, you guys will have a review assignment for Unit 8. And then on Wednesday, the 15th, you guys will be taking a quiz on Unit 8. How that'll work is you will answer, it's going to be mainly multiple choice questions, probably all multiple choice questions. And you will have to submit your work on separate paper through Google Classroom, and then you'll answer the questions through it's problematic that will come up, and you'll answer through there and then submit that, and that will count as your quiz grade. I'll give you guys a window of time to do it in, and I'll send out that information to you as well. But I wanted you to start planning ahead that would be coming up next Wednesday, would be your quiz. Okay, and then also I'm planning to give you the snow day that we missed on the 17th, so Friday. So then you wouldn't have any work after your quiz, and you could have a little nice long weekend until Tuesday. All right, so back into synthetic division. It's just a pattern that we kind of can use to make long division a little bit shorter. So whenever you're going vertical, think vertical goes up and down like this. You can make a plus sign out of a vertical line, right? So this is anytime you're going vertical, you're going to add. So you're always going to add when you're going down. And then along your diagonal, think about for a diagonal, you can make an X, which is the symbol for multiplication. So anytime you're going diagonally, you're multiplying, and you're always multiplying by K, which is this out here. So what this represents here, the A, B, C, D, and it gets a little confusing with all the letters, so we'll dive right into an example after this. But this is the A, B, C, D are coefficients of a polynomial. So you'd go up in exponents by 1. So this would be ax to the third plus bx squared plus cx plus d. So that is our dividend. And we're dividing that by our divisor. So if k is your root. So we're dividing it by our factor of x minus k, which is our divisor. And then down here, you're going to end up with your quotient. And this last box over here will tell you what your remainder is. So if your remainder is 0, you know that k is a root and x minus k is a factor. If there is a remainder, then it's not x minus k is not a factor, and k is not a root. So the other thing that's really important to remember is that this algorithm only works for divisors in the form of x minus k. So that's the same thing as saying x plus k too, because you could have minus and negative k is the same thing. That's really important. So if you have something like 2x plus 1 as your divisor, if that's your divisor, then you need to use long division. It's not in x minus k form because it has a 2 in the front of it. If I ask you to divide as your divisor was x squared minus 2, you cannot use synthetic. You have to use long division because it's x squared. It has to be x plus or minus a number. If you had x plus 5, then yeah, you could do synthetic division or long division. So long division will work with any of them. Synthetic's only going to work if it's x plus or minus a number. So you don't want a coefficient in front of x besides 1, and you don't want x being raised to any other power than 1. So here's how it will work. First, you take your factor as x minus k, so we put a k outside here. The first one, you're going to drop it down. That's a. Now, every time we go up on this diagonal, think that you're multiplying, and you're always multiplying by k. So this would become k times a. Then when you're going down, think you're vertical, you're always going to add. You can make a plus sign out of that. So it'll be b plus ka. And I'm not going to continue because it gets too confusing with all the letters. But in the end, whatever number's here, that's going to be your remainder. And then you're just going to add back in your x's for your answer. So let's take a look at that. Take this part out because we didn't have a warm up. Number 1, 2x squared plus 10x plus 12 divided by x plus 3. When we do this, again, you want to make sure you count down by ones as your exponents. So this goes 2, 1, and then none. So we're good there. We don't need a placeholder. So we want to take 2x squared plus 10x divided by x plus 3. So x plus 3 is going to be your factor. So you want the root or the 0, which is your k value. So in this case, you're always going to take the opposite sign. So think about it as setting this equal to 0. You'd get x equals -3. This is really important because it can be given to you different ways. So really make sure you know, is it a factor? If it's a factor, then it'll have an x there. If it's the root or the 0, then you won't have an x. It'll just be the number. X equals a number. If they write x, it'll be x equals. So what we do first is we're going to take the coefficients of our dividend. So we take the coefficient of x squared is 2, the coefficient of x is 10, and the coefficient of x to the 0, or just nothing, the last term, constant, is 12. I draw my little box, and then I take my root, which is -3, and put it on the outside. So probably most common mistake is that people mess up this part on the outside, which will really throw off your answer. So you want to have the root, so that's -3. First step, drop it down. So 2, just bring that straight down. Now we're going to go diagonally up. Remember, diagonal, we can make an x for multiplication, always multiplying by the number on the outside. So 2 times -3 is -6. And when I go down, I'm adding. Make a plus sign out of that. 10 plus -6, or 10 minus 6, is 4. Going back up, so I'm going to multiply. Always multiply by the value out here, the root. So -3 times 4 is -12. Going down, so I'll add 12 minus 12 is 0. So the last number always tells us our remainder. So we have a remainder of 0, which tells us that x plus 3 must be a factor. Now to write out our answer here, or our other factor, you're going to take, I always start from the end here, and the last term is going to have no variable. The next one's going to have x to the first, and then x squared, and then x third, whatever you need, and so on. So here, our final answer would be 2x plus 4, so our quotient, if we divide those two. We know that 2x plus 4 must also be a factor because there is no remainder. So that's something else. It didn't ask us for that, but just something that's important to take note of is a factor because there's no remainder, and the remainder is 0. So we know that if I took 2x plus 4 times x plus 3, it would give me 2x squared plus 10x plus 12. So that would have been factorable using P's and C's. All right, number 2, use synthetic division to divide x to the 4th minus 10x squared minus 2x plus 4 by x plus 3. So x plus 3, again, you were given it as a factor, but we're going to want the root for synthetic division. So you need to use the opposite sign once we set this up. Also, make sure that it counts down by 1. So I go from x to the 4th to x to the 2nd. Uh-oh, I'm missing 1. So I need to use a placeholder for that missing spot. So it'll be x to the 4th plus 0x to the 3rd, then minus 10x squared, minus 2x, 2, 1, 0. Okay, so now let's see what we do. We're going to take our coefficients. So the coefficient of x to the 4th is 1. then we have a 0, then a negative 10, negative 2, and 4. So you can see here why that placeholder is important. On the outside, remember we're taking our root. So if our factor is x plus 3, we're going to take x equals negative 3. So negative 3 on the outside. We're going to first drop it down, becomes a 1. I'm going back up, so I'm going to multiply on the diagonals, always multiply by the number out here. 1 times negative 3 is negative 3. Going down, so I'm going to add 0 minus 3 is negative 3. Back up, multiply negative 3 times negative 3 is 9. Negative 10 plus 9 is negative 1. Again, going down, I add. Going back up, I'm going to multiply. Negative 1 times negative 3 is 3. Add going down, negative 2 plus 3 is 1. Going back up, I multiply. 1 times negative 3 is negative 3. And going down, I'm going to add. 4 minus 3 is 1. So now I know here that my remainder is 1. So I know right off the bat right now that x plus 3 is not a factor. X plus 3 is not a factor of the original. We'll write it out. X to the 4th minus 10x squared minus 2x plus 4, because there is a remainder. So it does not go in evenly. Our answer now, again, we're going to take our last term here, and that's going to be our constant, so no variable. Then this gets an x squared, x to the 3rd. So you just count up. So final answer is x to the 3rd minus 3x squared minus 1x plus 1. And then we're going to write it in that same form we did with long division, plus our remainder, which is 1, divided by our divisor, which you use the whole factor, so it would be x plus 3. And that's your final answer. Again, it didn't ask us here, is it a factor? I'm just adding that information on because it's important. So this is your final answer once you divide using synthetic division. Number 3, find all the zeros of f of x given that negative 1/5 is a 0 of f. Write your answer in simplest, a plus bi when appropriate. So this time they gave us negative 1/5 is a 0. So if you're given the 0 or the root, then you want to keep the sign. We are not given the factor. If we were given the factor, it would have said x plus 1/5 for that. Okay, so we're given just the root. Also, right here, we also know that our highest exponent is 3, so we know we're going to have 3 roots or 3 zeros in our final answer. And it's asking us to find all 3. We already know one of them is negative 1/5. We need to find the other 2. So since I know that negative 1/5 is the 0, or x plus 1/5 is the factor, if it's x plus 1/5, I'm allowed to use, or if I have the 0 or the root, I can use synthetic division. You also could use long division, but for that you would have had to use the factor of x plus 1/5. Let's make sure that the exponents count down. So we have x to the 3rd, x to the 2nd, x to the 1st, and then nothing, so that's good. So I'm going to take my coefficients, which is 5, negative 9, 28, and 6. On the outside, I'm going to put my negative 1/5. Now I'm going to drop down the first one, that's 5, going up. So negative 1/5 times 5 is going to give me negative 1. Going down, so I'm going to add to get negative 10. Going back up, I'm multiplying negative 10 times negative 1/5. It's going to give me a positive 2. Going down, I'm adding 28 plus 2 to get 30. Going back up on the diagonal gives me 30 times negative 1/5 is negative 6. Add going down, 6 minus 6 is 0. So my remainder is 0. So I have no remainder. Therefore, I know this is a factor. X plus 1/5 is a factor, or you also know that negative 1/5 is a 0. Now we already knew that, the problem told us that. So if you didn't get 0 for your remainder, then something went wrong. So that's when you want to go back and try to figure out where you made your mistake. The question's asking us to find all the zeros. So what we just did didn't find us any more zeros, it just broke it down to something a little bit more simpler that we might be able to work with easier. So now I know that this, if I can leave this as a constant, put my x and my x squared here, I've got 5x squared minus 10x plus 30. So this is just like what we did with long division when we were finding the roots. Now I can break this down to find the rest of my roots. I need 2 more. Now I have a couple hints here. It said that my answer should be an a plus bi form. So as soon as I'm looking at that, I'm thinking this is probably not going to be factorable. But maybe I missed that hint. So maybe I factored out a 5 from each of these to see what happened, see if I could factor it. I get x squared minus 2x plus 6. And then I say, okay, well, this is going to equal 0 because I want to find what those roots are. And I'd say what multiplies to 6 and adds to negative 2, and it's not factorable. There's nothing that multiplies to 6 and adds to negative 2. So therefore, we need to use your quadratic formula or completing the square. I'm going to do quadratic formula today. So let's write it out. Hopefully you can sing your song in your head. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we're going to substitute in. Now, it's okay if you use the original. Your a is 5, your b negative 10, and your c 30. And it's also okay for you to use this quadratic right here. So that is up to you. I'm going to use this new one right here. So I'm going to use my a is 1, b negative 2, and c 6. So now I have negative b. So my b is negative 2, so that's going to become a positive 2. Negative 2 must be in parentheses, squared minus 4 times a is 1, c is 6. Extend that. 2 times a, which is 1. Go to my calculator, type this in my calculator without the radical, very, very important. And that's 4 minus 24, which is negative 20 over 2. I cannot reduce here. Here's where I lose a lot of students because they try to divide everything by 2 or try to simplify these 2's in the front. Neither of which you can do at this point. You first need to put this into simplest radical form, or you could separate into 2 fractions at this point if you wanted to. I'm going to put this in simplest radical form first. So I'm going to pull out an I. My largest perfect square I can take from 20 is 4 times 5. So the square root of 4 is 2. So now I have 2 plus or minus 2i rad 5 over 2. And now I'm going to split it. So I have x equals 2 over 2 plus or minus 2i rad 5 over 2. And 2 over 2 reduces to 1. These 2 cancel out to 1. So I get 1 plus or minus I rad 5. And it has to be written separate if there was that denominator on the bottom. Very important to split up those fractions. And our final answer then, because that gave us 2 zeros, our zeros are going to be negative 1/5, 1 plus I rad 5, and 1 minus I rad 5. Could you write it as 1 plus or minus I rad 5? Absolutely. That would be fine too. And again, that number of zeros, double check your number of zeros should equal your highest exponent. So our highest exponent was 3, and we have 1, 2, 3 different zeros. Okay, so that's synthetic division. Hopefully that seems a little bit shorter and faster than long division. Just remember that you can only use it when your factor is x plus a number or x minus a number. In this case, we're calling the number k. Otherwise, you have to use long division if it's not. All right, I hope you're all staying healthy, staying happy, having fun, doing math dances, and loving math, of course. And I will hopefully see you soon. Pi out.